Okay, so today we're going to be looking at the 8C topic, which is looking at the lungs and how the lungs are adapted and how the lungs work. So today I'm actually going to be doing a lung dissection. If you are squeamish, you may want to maybe not look at this, but maybe just write notes instead. So I have here a set of lungs that we are going to dissect. They are not human, so you don't need to be worried about that. They don't look great in the bag. So I'm just going to empty these out onto the dissecting board, and then I'll start talking you through the different anatomy. So it doesn't look like too much just there. Got my tools in Dettol, which is the white stuff. It's not milk, which is what often students think it is. So let's just arrange these so they look like lungs. That's just where the heart's been attached. So I'm actually going to cut all this off first. Okay, so let's look at the lungs then. You can see where the heart was attached down here. Looks like there's still a bit of cardiac tissue attached. Now, first thing is you may notice, sorry, you can see where all of this has been. I'll just chop this off as well. You may notice that there's big cuts in each of the lungs here. Now, obviously, I've not done that. The reason that gets done is by the butcher or the person who works at the abattoir will put cuts in each of the lungs, basically just to check for disease before selling the meat, just to make sure that they are fine to sell, etc. So, let's start at the top. Obviously, this would be much longer. This is the trachea that we're looking at here, this part here. The trachea actually has rings of cartilage that line all the way up. If I show you like that, you can actually see some of the rings. And basically what those rings of cartilage do, so you can see them just there, is they support the trachea and stop it from collapsing in on itself like that. So they keep it open. So obviously the air can pass down the trachea and into the separate lungs. So the trachea will often, although this one doesn't, I can't see any just yet, will often have mucus in it as well. That is to trap dirt and any pathogens that you may breathe in to stop it getting to the lungs and causing infection. Okay, you can actually see quite nicely down here, down the trachea, that the trachea splits into, and you can see that hole there, splits into the bronchi. Now, the bronchi split the trachea into each of the lungs, and unfortunately this is where it's already been cut. So you can see there's one bronchi there, which would normally be taking the oxygen into that lung and taking the carbon dioxide back out to the mouth. Now, the bronchi deliver oxygen to this lung, and then you can see they split into smaller and smaller, you can just see them there, smaller and smaller tubes called bronchioles. So just to recap, trachea, also known as the windpipe, splits into the bronchi then split into bronchioles, smaller branches. Now what you would find at the end of the bronchi, so you can see lots of little holes here, smaller ones further down. You can see where, if I squeeze and bubbles are formed, it's basically where air's been trapped, so you can see more of them. So if I just squeeze like that, you can see some bubbles forming, especially that one there. Same on this side. This one's a more pronounced one, so the bronchi's gone into this lung. It's then split up into these smaller and smaller tubes called the bronchioles to get oxygen to all the parts of the lungs and to take carbon dioxide away. Now, you won't be able to see the next bit, but at the end of each bronchi, you actually have you actually have alveoli, or an alveolus is one. And what the alveoli do, that is where gas exchange actually takes place. So that is where oxygen enters the blood and where carbon dioxide leaves the blood, goes back into the lungs, and is breathed out. Now, your alveoli, as I've said, you won't be able to see them, but that is what makes the lung so light. I mean, this lung is really light. It's a healthy lung. You can tell it's pink because it's got a good blood supply. Now, if you smoke, your lungs can actually have a black appearance, which is caused by the buildup of tar and the dead tissue. So they're really light. If I was actually to chop this bit off and put it in water, it would float. And that's because it's filled with air in those little air sacs called the alveoli. If I had a syringe, what I'd be able to do is put the syringe down one of these bronchioles, and I'd be able to inflate it, and you'd be able to see the lungs expand. So, alveoli, the little air sacs, which is where gas exchange happens, they are really important, and they're actually really well adapted for gas exchange. So they have a large surface area, so lots of oxygen can move into the blood and lots of carbon dioxide can move away. They are moist, so that oxygen can dissolve and move into the blood slightly easier. They have really thin walls between the alveoli and the capillaries, and that makes diffusion really fast, so oxygen doesn't have to pass through a big, thick pathway to be able to get into the blood. Same with carbon dioxide leaving. Now, one thing that you can't see on this lung is obviously you would have the ribs protecting the lungs, and at the bottom you would actually have, and it's like a sheet-like muscle called the diaphragm. Funny fact for you, when you get hiccups, it's actually because this muscle called the diaphragm, which as I've said is like a thin sheet, is spasming. So when that spasms, that's what actually gives you hiccups. Now, when you breathe in, and I want you to sit now, take a big deep breath in, you will notice that your ribs move up and out. So they move up and out, and that increases the volume of your chest. And when it does that, your diaphragm, that muscle, also flattens and moves down, again, increasing the amount of space that these lungs have to expand. Now, when that volume increases, the pressure decreases. So what happens is air then rushes into your lungs and you fill your lungs. And that's called inspiration. Now, when you breathe out, it's the opposite. So I want you to take a big deep breath in and then breathe it out and notice what happens with your lung, what happens with your ribs. Your ribs move down and back in, and your diaphragm also relaxes and moves up. Okay, so your diaphragm sits under here when it's relaxed, it moves back upwards. Now, what that does is it decreases the volume in your chest, and that increases the pressure. It forces all the air out. So all that carbon dioxide, that waste gas that you're trying to get rid of, is then forced back out of the lungs. And that is the lungs for you. Any further questions, please come and ask any of your science teachers and we'll go through it. Hopefully you didn't find this too gory today. And if you've got any other questions about dissections, please come and find us. Thank you.